Anna, and I'm going to be testing the reaction between acids and bases. So for this experiment, I'm going to need 1 egg, a clear glass cup, and some vinegar. So I'm using an egg because its egg shell is made up of calcium carbonate, which is slightly basic, and I'm going to be using some vinegar, which is made up of 5% acetic acid. So for this experiment, I'm going to start off by placing the egg inside of the cup, and then I'm going to add my vinegar. And I'm going to make sure that it's covering the whole egg. Right away, I can start to see some bubbles forming in the experiment. Now I'm going to put it to the side and wait a few days. So it's been about 24 hours since I put the egg in the vinegar, and as you can see, there are some bubbles forming around it and on the surface of the vinegar. There's also a white substance at the surface, which is probably the shell starting to come off, and the egg is more beige compared to the original egg, and a lot bigger as well. So it is the 3rd day of the egg being in vinegar, and a few things have happened. There are fewer bubbles on the surface of the vinegar, as well as the egg has changed color and seems much more transparent than before. If we compare it to this smaller egg, it's a lot darker than this white color here. And this is probably because the shell has completely fallen off or dissolved into the vinegar. And the egg is obviously much bigger than it was before. So it is the 4th day of the egg being in vinegar, and it is very translucent and has lost almost all of its shell. It's day 5 of the egg being in vinegar, and the egg is again very translucent with many bubbles around it.
The egg is a little more translucent with some yellowy colors. Yeah, but otherwise it looks kind of the same with the same number of bubbles. And I think the little chunks at the top have almost completely dissolved. There's just a few of them left. Yeah.
So it's the final day, and I'm about to take my egg out of the vinegar and see what it looks like. But my final thoughts on the egg are that it has become very translucent. There are still some bubbles formed around it, and it's a lot bigger. There are little bits of calcium that's stuck to the cup, possibly from the shell itself that didn't completely dissolve in the water. So after taking the shell out of the vinegar, it's a lot softer, and as you can see, it's being held together only by the membrane of the egg. What happened was a double displacement reaction in which the calcium carbonate that made up the shell of the egg bonded with the acetic acid that was in the vinegar, and that formed calcium acetate, carbon dioxide, and water. The solution that we saw, or the liquid in the cup, was calcium acetate solution and water, and the bubbles that formed around the egg were carbon dioxide gas. The reaction formed a neutralization, which created water, and both the pH of the egg and the acid were closer to a pH of 7. This experiment can show how acids and bases are used in our everyday lives, and how acids can ruin your teeth. The eggshell is similar to our teeth, because they're both made up of calcium and are basic. The plaque or enamel that builds up on our teeth are acidic, and without toothpaste, our teeth would act as the eggshell and eventually dissolve. The fluoride in our toothpaste helps to protect our teeth and stop this reaction from happening. So it's important to brush your teeth.